Bismillahirrahmanirrahim. Dear students, in previous class I have explained the clean theorem, the three parts of the clean theorem, and I have also proved all those parts. Okay, so now in this lecture we will discuss about the DFA, or we can say deterministic finite automata. So in very first lectures of DFA, in very first lecture of the NFA. So look at this, I have divided FA, or we can say finite automata, into two portions, if you remember. So I have explained it that FA, or we can say finite automata, I have divided it into two portions. So one was FA with output, FA with input and output, input and output. And the second portion, the second type is FA with input with input having no output. Yeah, there is no representation of output here we have. Okay, so there is no output in this. We are not representing the output. We are not writing the output of this. Okay, so we are just writing the inputs letters. Okay, and then we divide this, and the example of without output are more machine. Yeah, we can say more machine, and the second one is Mali machine. These are the example of FA with output, Mali machine. And this is an example of NFA that we have non-deterministic finite automata. To now we have discussed about the NFA. So the second one that we have without output is DFA, deterministic finite automata. Deterministic finite automata. So we have discussed this. Okay, so all the previous lectures were related, including the FA diagram, were NFA. So now we will discuss about this portion, DFA, yeah, finite, it is deterministic finite automata, and these two will be discussed in the coming lectures. Okay, so now this portion I will discuss, which is deterministic finite automata. So what is this deterministic finite automata? Let me just discuss it. In DFA, look at this. In DFA, for each input symbol, one can determine the state to which the machine will move. Hence, it is called deterministic automaton. It has a finite number of state. The machine is called deterministic finite machine or deterministic finite automaton. Okay, so now what does it means in case of NFA? For example, if I'm drawing in NFA, for example, Q0, this is initial state and this is final state. Yeah, we can say this is Q1 and third one is the final state. You know about this, that how will we represent initial state, how will we represent final state. For example, this is Q2. Okay, this is Q2. For example, alphabets are A, B. For example, alphabets are A, B. So we have just only two letters in this alphabet. So one is A and one is B. So here we have a transition from Q0 to Q1, that is for A. And we have transition from Q1 to Q2. So that transition is, for example, B. One more thing, for example, I'm taking a transition for Q2 from Q0, and that transition is A. So here, in case of NFA, so we can have two transitions with same input symbol. Look at this. For example, from Q0, we have a transition toward Q1, and the input is what? The input is A. Here we have also transition from Q0, and that transition moves toward Q2, which is final state. It is also an input symbol is A. So now this is not allowed in DFA. This is not allowed and DFA. So two transition with same letter to two different state, so that is not allowed and DFA. Okay, so this is allowed just only an NFA, not allowed in DFA. Okay, so here one more thing, in this definition there is no did configuration and the DFA. So I will discuss about this later also, but here keep in mind that there is no did configuration. So now to explain this definition, so there is no did configuration is allowed. This sentence means that for each input symbol, one can determine the state to which the machine will move. So for this statement, so we can say that there is no did configuration in DFA. What does it mean? Look at this. So here, how many letters we have? We have two letters, A and B in this alphabet. Okay. So now, when you look at this diagram, so we have a transition from Q0 for A, but there is no transition for B. So this is called the did configuration. So did configuration چی است؟ did configuration مقصدی است که اینجا یک state ما داریم که او Q0 است یا Q0 است. امی Q0 کدام transition داره؟ اینجا transition A داره و اینجا transition A داره. خود ترانزیشن بی هیچ نداره. صحیح است؟ نو مقصدی است که ترانزیشن بی did است. did مقصدی است که it will not be accepted at final state. For example ما اینجا یک Q3 ما میگیرم. صحیح است؟ We can say this is did state for B. So it is not accepting on final state. ای با final state چی است؟ accept نمیشن. وی did state است. ما بیخی نوشته نمیگیریم. صحیح است؟ ما بیخی درا نمیگیریم. اگر بیخی درا نباشه it means که این did configuration است. نو the DFA did configuration allowed نیست. خود NFA allowed است. the DFA allowed نیست. اگر اینجا شما سعی کنین the NFA it is allowed. Okay, and it is accepted that, for example, here we have a transition for B, but there is no transition for A from from Q1 state. اینجا از Q1 state transition B است خود transition A نیست. حالانکه A موجود است اینجا د چی د الفابت موجود است خو هیچ transition نیست. نو مقصدی است که او did transition است. did transition مقصدی است که for example ما میگه Q4 است. نو اینجا the final state each except نمیشه. ای بیخی او طرف رفتن. صحیح است؟ نو did configuration است. the NFA allowed است خود DFA امی did configuration allowed نیست. امی قسم اینجا final state است. as final state نه transition A است و نه transition B است. it means که there is no transition for A and B. So here we have did configuration for A and B. اینجا did configuration موجود است. So it is accepted in the NFA but not accepted in DFA. the DFA قبول نیست و the NFA امی قسم قبول است که مقصد از یک transition مثال از یک transition از یک state transition A است B نمی باشد the NFA قبول است. فرق نمیکنه. مثل که اینجا از Q0 transition A اینجا است و transition A اینجا است. صحیح است؟ So this is allowed in the NFA but not allowed in the DFA. So the definition tells us that, for example, if we have two or three states. For example, q naught, this is the first state. Yeah, we can say this is the initial state. Okay, and the second one, q1, this is a state, and next we have q2, and I'm taking this is a final state. Same like in NFA, so we have initial state and final state. Also in DFA, so for example, this is initial state and this is final state. For example, we have the uh, alphabet A, B letters. Okay, so this alphabet has letter A and letter B, and I want to make the diagram from a DFA diagram from these letters. So now how will we have a DFA? So for example, if we have a transition of A, sorry, for example, here we have transition for A, there must be a transition for B also. For example, I have a transition B, okay, which is the loop. This transition is starts from Q0 and move toward Q0. So this is loop. For example, here we have transition B, and here we have transition A toward Q naught या Q0. ओके, मकसद ये था कि हर स्टेट वो ट्रांजिशन A में داشته باشه و ट्रांजिशन B में داشته باشن. صحیح است. For example, امی state است. So here we have transition A is a loop and it has a transition of B toward Q naught. Sorry, toward Q1. But Q0 رفتم میتونه مشکل نیست. صحیح است. So this is a DFA. We can say this is the DFA. اگر یک الفابت ما داریم صحیح است، set of letters اگر ما داریم و ما DFA جور میکنیم، صحیح است، according to the definition. So each state should have an input symbols for each letter, says, and that will be represented by a transition. Means a transition ما میگیریم برای هر letter. So اینجا از E دو transition است، یک A است و یک B است. از Q1 هم دو transition است، یک A است و یک B است. از final state هم دو transition ما داریم، یک A است و یک transition B است. So this is called the DFA. Okay, نو این DFA است و این یک state machine است. So here what we have, a DFA can be represented by a 5 tuple Q, this one sigma symbol asta, this is a small sigma, this is Q naught, and this is F. So when we are designing, when we are drawing a DFA diagram, so we will have these 5 things for the drawing of for making a DFA diagram. امی 5 چیزا هستن که با استفاده امی 5 چیزا ما DFA diagram رسم میکنیم. Here Q is a finite set of states. Sigma is a finite set of symbols called the alphabet. The small sigma is the transition function where Q multiplied by alphabet is Q. Q naught is the initial state from where any input is processed. Q naught belongs to Q. F is a set of final state, state of Q. F belongs to Q. So now what are these? So Q is a finite set of state. For example, if we have a DFA, so Q means that Q is equal to, for example, here we have Q naught, Q1, Q2. So I think let me just write it properly. for example, this is state Q0, this is state Q1, and this is state Q2, and this is also the final state. So now in this, Q is a finite set of states. So here we can say Q is what? Q is equal to Q0, Q1 and Q2. So Q represent the number of states. Yeah, Q represent these states. Inja chan state asta, say state asta. No Q, Q0, Q0, Q1, Q2 e say states asta ki modern sahi. So e as chi represent mesha as capital Q represent mesha sahi. So dom chi sigma is a finite set of symbols called the alphabet. For example, ما یک alphabet داریم سعیست و ما میگیم که alphabet کدام است؟ A و B است for example. Now sigma چی represent میگینه؟ امی set of letters represent میگینه که باز امو input می باشه دا DFA سعیست. امو input باز اینجا ما دا transition نوشته میگینم سعیست. دیگه چی است؟ Most important thing that we have is small sigma. So is the transition function where Q multiplied by sigma is Q. So what does it mean? This is a transition function for DFA. So it means that state, from state we will have a letter and it will move to the other state. So it represents just like this. Now transition as the transition chiksam bosha as yak state shuru misha. It will be a state, any state. For example, we have Q0 and will have an input. For example, I have an input right here A, and it will move to the other state. So the other state is what? The other state is Q1. So it means that in DFA, so the transition, sorry, first the transition function will be it will consist state which is Q0 for this and his a letter. So it means that Q0 multiplied by A, so it will move to which state? So it will move to Q1. So now, for example, if we have transition like this, for example B, so how will we represent this transition? So the representation is what? The representation is small sigma, and it will be represented just like this: Q1 multiplied by B, and it is moving toward Q2. So here, for example, we have in another transition which is loop B. So how will we represent this transition? So this transition is represented by this sigma and Q0 multiplied by what is the input is B, is moving toward Q0 to same state. No, it is just like this. क्यों किया आमी स्टेट रिप्रेजेंट में किया ना कि मकसद आमी इनपुट की रफ्ता या आमी ट्रांजिशन की रफ्ता कदम स्टेट रफ्ता वो कदम इनपुट दारा वो बा कदम स्टेट रफ्ता सही है. So this is the representation of transition function. Next, Q0 is the initial state from where any input is processed. Okay, you شما میفهمین که این چیز Q0 که است یک state می باشه و initial state است. این خب ما گفته بودم صحیح است. For example, this is initial state و F is a final state. F یا اینجا ما double circle اگر ما میگیرم یا بجایی اگر شما فقط F نوشته میگینی نو F چی است final state می باشه صحیح است. It is also belongs to Q مقصد state in the chimi washa the state me washa. So these are the 5 tuples through which we are representing it includes inside the DFA diagram. tuple DFA diagram bud peshazi ma DFA یک مثال تشریح کردم، صحیح است، تعریفش تشریح کردم. بعد از این دیگه مثالم هست، امورم باز ما تشریح میکنم و باز فرق بین DFA و NFA چی است او را باز ما تشریح میکنیم و چند مثال باز ما کار میکنیم، صحیح است. These will be the part of the next lecture. So if you have any question related to DFA, so then you can ask. Okay, so it's enough for this lecture.